Hello student, let us start the fifth video of your chapter number 8, motion. Till now in this chapter we have discussed so many things about motion, what is displacement, what is distance, what is uniform motion, what is non-uniform motion, and that what is speed and what is velocity and what is acceleration and so on. So in today's lecture we will introduce a graph, that how to represent any kind of motion with the help of graph. Okay, and how we can interpret those graph, and with help of those graph what are the physical quantity which we can extract out. Okay, so let us start. So the title would be the graphical representation of the motion, and first question which comes to our mind is why we use graph. So yes, question you may also have, that why the graph is needed to represent something. The answer is, the graph is very convenient tool of mathematics with the help of which we can represent many things very effectively and simply. Remember the cricket match you used to watch, in which India is batting, and the runs made by Indian cricketer has been demonstrated by the graph, the bar chart. So it is very fascinating. So like that, graph is a very effective tool to represent many things. So today we are going to discuss that how graph will play the role in motion. So in our syllabus there are two types of graph. One is the distance time graph and another is the velocity time graph. So let us discuss them one by one. So first is the distance time graph. Now here we will take two examples. One is the uniform motion and another is a non-uniform motion. So uniform motion, as you people know, that if object is covering the equal distance in equal interval of time, then that kind of the motion is known as a uniform motion. For example, in 10 seconds, the object has covered 100 meter, next 10 seconds 200 meter, that means then next 10 seconds 300 meter and so on. So in each 10 seconds, the displacement or traveled by the object is 100 meters. So same example I have taken over here. So in 10 seconds the displacement is 100, in 20 seconds it is 200, in 30 seconds it is 300 and so on. So this is nothing but the graphical representation of uniform motion, wherein on the x-axis I have taken time, on y-axis I have taken a distance. So time is taken in second and the distance is taken in meter. So by joining all three points A, B and C, I am getting a straight line, and the straight line of distance time graph represent that it is a uniform motion. Okay, so straight line is also known as the linear graph. Okay, now one more information which we can extract out from this graph is the knowledge about the speed or velocity. So the speed of velocity for this graph is change in y-axis divided by corresponding changes in x-axis. So here let's say I am taking 2 points B and C. So change in y-axis, that is S2 minus S1. So displacement here S2 is 300 minus 200, and corresponding changing in x-axis, that is time is 30 seconds minus 20 seconds. So 300 minus 200, 100, 30 minus 20, 10. So here the velocity which we are getting is 10 meter per second. So from this distance time graph, if we are taking the change in y-axis divided by change in x-axis, then it is giving us the knowledge about velocity or speed. In mathematics, such thing, when here the change in y-axis upon change in x-axis is also known as the slope of the graph. Is known as the slope of the graph. We can also take the example of the non-uniform motion. You must be remembering what is the non-uniform motion. Non-uniform motion is the motion in which object is not traveling equal distance in equal time. Here you can see in this table, in 1 second it has traveled 1 meter. Let's say it is in meter, not in second. So in 1 second it has traveled 1 meter, in 2 seconds 4 meter, 3 seconds 9 meter, in 4 seconds 16 meter, in 5 seconds 25 meter. Now if I represent the same thing on the graph, I am getting the point A, B, C, D and E, and if I join them all, I am getting a line which is not linear, so this is non-linear. So if in the distance time graph, if something non-linear kind of pattern of the graph is there, then it is certainly not a uniform motion, it is a accelerated motion. So here the object is accelerating. So this is what the distance time graph is. Let us proceed toward the velocity time graph. So the only change in distance time graph and velocity time graph is here. The x-axis will remain same, it is always a time. The y-axis is velocity instead of displacement. So here y-axis is velocity. Now here I have taken an example in which the uniform velocity is there. That means the velocity of, let's say, car is not changing with time. It has started and it has attained the velocity of 50 km per hour. After 2 hours it is also 50 km. After 3 hours also it is 50 km. Okay, so velocity is remaining constant. But if I have to represent the same thing, that means this constant velocity on this distance time graph, then this line will not be horizontal. It will be something like this, because distance is increasing here, velocity is not increasing. But if it would have been a distance, not velocity, then it will be certainly increases. Okay, so this is the velocity time graph. Now as we have extracted the information of speed here we will be having we can get the information about the displacement. We know that velocity is displacement upon time. So displacement is equal to velocity into time. So graphically as well, if I want to find that from point A to point C, that means from t is equal to 1 second to t is equal to 3 seconds, how much distance a car would have covered. So the only thing I have to do is V into t. Now what is V here and what is t here? So this vertical axis is velocity, this horizontal axis is time. So if this is the square, I can say displacement is the area under the curve, and area of this rectangle is nothing but length into breadth. So it is A into E, that is a velocity. This is nothing but the velocity. This thing is velocity, and this thing is nothing but the time. So AE into AC. So velocity is here 50, time is 2 hours. So 50 into 2, that is 100, and it is in kilometer. So from t is equal to 1 to t is equal to 3 seconds, the displacement of the car is 100 kilometer. Okay. Let us discuss the example in which the velocity is not uniform. So it is a non-uniform velocity. Non-uniform velocity. So what is this non-uniform velocity, or what this kind of motion is called? It is called the accelerated motion, where the velocity keeps on increases or velocity keeps on decreases. But the condition is it increases or decreases in some special form, in some special pattern. It is not increases or decreases haphazardly. It is increases or decreases systematically. So this is the example in which the table shows the data in which t is equal to 0 hour, the velocity is 0, and t is equal to 1 hour, velocity is 10, t is equal to 2 hour 20, and 3, 30, 4, 40. Okay, so here at 1 it is 10 and so on. So I am getting point A, B, C and D. So I am getting almost the same graph which I have discussed here. This graph is also a linear graph. Okay, so you can remember that when we are getting the linear graph on the velocity time axis, it is the accelerated motion, and when we are getting the linear graph of let's say distance time axis, it is a constant uniform velocity. Okay, now here also as I have discussed, the area under the curve will give me the information about displacement. So let's say I want to figure out from point B to C, that means let's say from time t is equal to 2 hour, from time t is equal to 2 hour to t is equal to 3 hour. what is the displacement covered, traveled by an object? So once again I need to take the area under the curve. So this entire area I have to calculate. But here you can see it is not simple as that, because here it is the rectangular. So simply it is length into breadth. But here it is some weird shape. So I have to bifurcate two things here. So one is this area. This rectangle is there. And one triangle is there. Now we have to first calculate area of this rectangle and the area of this triangle, and we have to add them, which will give us the information about displacement from B to C. So let us calculate. So here this is 20, 0 to 20, and here it is 1. So 20 into 1 plus area of a triangle is 1/2 base into altitude. So it is 1/2 into base is 3 minus 2, 1 into altitude is 30 minus 20, 10. Okay, so this is 20 plus 5. So 25 kilometer. This is the answer. So here from t is equal to 2 hour to t is equal to 3 hour, the displacement traveled by the object in this non-uniform velocity graph is 25 kilometer. So I hope you will be able to calculate now the velocity or displacement from the graph which is given distance time on the y and x axis or velocity time on the y and x axis respectively. Let us proceed further. So here there is a non-uniform motion of velocity and time graph. In the previous graph we have seen that velocity, when it is increases, it is called a uniform velocity. Similarly, when velocity is decreases, equal decrement is there in equal interval of time, then also it is known as the non-uniform velocity. Is in non-uniform velocity. So here you can see the velocity is decreases when, let's say, you can consider that this is the case when a driver is driving the car at a constant speed, but there is some obstacle on the road and he suddenly applies the brake. So car is moving at the speed of 50 meter per second. He applies the brake. So after 1 meter, the speed has been decreased to 40. After 2 seconds, it is 30. After 3 seconds, it is 20. And after 5 seconds, that vehicle eventually stops. So this is the decrement in the velocity. But here, the velocity decreases in systematic manner, systematic fashion. Okay. So as we have seen that from the distance time graph, the slope is giving us the velocity or speed. From the velocity time graph, we will be able to find the acceleration. Now here acceleration is also nothing. It is change in y-axis divided by the corresponding change in x-axis. So let us consider 2 points once again, C and D. So change in y-axis is for C and D, it is 30 minus 20. And this is 2 minus 3. So 30 minus 20, 10. 2 minus 3 is minus 1. So here the acceleration we are getting is minus 10. And remember, when acceleration is negative, what does it represent? It represents that it is decreasing the velocity. The direction of acceleration and direction of velocity is reverse. So here eventually that vehicle or any object slowing down. Here I have seen, I have demonstrated a completely haphazard graph of velocity and time. So here the velocity sometime increases, then suddenly decreases. So it is a completely random graph and it will not able to give us any concrete information about which kind of the motion is there. Okay, now let us, two very important activity has been given in your textbook. So let us discuss those activity. First of all, activity 8.9, which is given on the page number 106. Table 8.4 is there, and in that some information is given. that station A, B and C is there. The distances of station B and C from station A has been given. The train comes to station A and then it arrives, then it departs and it comes to station B, then it departs and eventually it comes to C and then it departs. Okay, so from this information which is given in this table, we need to figure out that what is the we have to draw rather the plot and interpret the distance time graph for train, assuming that its motion between any two station is uniform. Okay, so here the distance between station A to B, as you can make out from the information given, is 120 and B to C is 180 minus 120 is 60. Now, so train is leaving station A at 8:15 and it is arriving station B is 11:15. So 11:15 minus 8:15 is 3 hours. So 150 is a distance, 3 hours is a time. So between A and B, the velocity is 40 km per hour. Now for B and C, the distance is 60. It is leaving at 11:30 and it is reaching at 13. So it is 1.5 hour. So 60 upon 1.5 is once again 40 km per hour. So what we can say, from A to B and from B to C, the speed or velocity of the train is 40 km per hour. Now to represent that into graph, so this portion is 4, let's say this is A and this point is B. So it is leaving at 8:15 and it is reaching at 11:15. This is 8:15 and this is 11:15. So in 3 hours it has traveled. This is distance 120 km. Now this portion is crucial. So from 11:15 to 11:30, the train is stagnant. It is not moving. So here I have only represent this horizontal line between, let's say, this B and let's say B dash. Okay, and from B dash to C, actually I cannot write B dash, but let's say this is B1 and B2. Okay, so this is B to C. Once again it is moving with the uniform velocity, which is once again 40. So the slope will almost same. So from 11:30 to 12:30 and 12:30 to 1, that is 30, it has traveled another 60 km. Okay, so here it has traveled 120 km and here it has traveled 60 km. Okay, so this is the graphical representation which is given in your activity 8.9. Let us proceed further to activity 8.10, which is given on page number 107. So Firoz and his sister Sania go to school on their bicycles. Both of them start at the same time from their home but take different times to reach the school, although they follow the same route. Table 8.5 shows the distance traveled by them. Plot the distance time graph for their motion on the same scale and interpret. So here the thing is, like I have already written on the board that time, the distance traveled in different time by Firoz and by Sania. So let us try to plot this. So at 0, let's say for Firoz, this is at 0, it is 0. At 8.5, it is 1. So here this is, and 8.10 it is 1.9. So 1.9 is slightly less than 2. So it is somewhere here, okay, just below. So it is here. At 8.10, now 8.15 is 2.8. So 2.8 is slightly below 3. So it is here. And at 8.20 it is 3.6. So I think this should be, yes, it is here. And 8.20 it is 3.6. So it is here. Okay, so this is the corresponding points of how the Firoz has traveled. Okay, almost, yes. So this is how the Firoz has traveled. Now for Sania, at 0 it is 0. At 8.5 it is 0.8. So 8.5, 0.8, it is somewhere here. Okay. Then 8.10 it is 1.6. So 8.10 it is 1.6 is here. Then 8:15 it is 2.3. So 2.3 is here. Then 8:20 it is 3. 8:20 it is 3. It is somewhere here. Okay. And 8:25 it is 3.6. So it is here. So graph is roughly somewhat like this. Not exactly, but it is roughly somewhat like this. Okay, so this is graph by Firoz and this is graph by Sania. So here what we can interpret from this graph is the speed or velocity of Firoz is higher than speed of Sania, and you can obviously figure out the speed if you take the here 2 points, then y2 minus y1 upon x2 minus x1. Okay, similarly for Sania. So this is how on the distance time axis we can represent the data which is given on the activity 8.10. Okay class, so in today's lecture we have seen how we can demonstrate the motion on graph, be it a distance time graph or be it a velocity time graph. Okay, thank you very much.